Tonight, there is nowhere you need to go, nothing you need to solve, nothing you need to remember. You can allow your breathing to slow, your thoughts to soften, and your awareness to gently widen. Tonight, we are going to drift toward one of the quietest, deepest mysteries in the universe. Not quickly, not dramatically, but slowly, as if the universe itself were whispering. We are going to talk about black holes, not as monsters, not as dangers, but as natural, patient features of reality. To understand black holes, we begin with something simple. We begin with gravity. Gravity is the gentle pull that keeps your feet on the ground. It is the reason planets orbit stars. It is the quiet force shaping the universe on the largest scales. Every object with mass has gravity. The more mass something has, the stronger its pull. A planet pulls gently. A star pulls more strongly. And when a star becomes unimaginably massive, gravity begins to change the rules. Imagine a star many times larger than our sun. For millions of years it burns steadily. Hydrogen fuses into helium. Energy pushes outward, balancing gravity's inward pull. This balance keeps the star stable. But stars do not burn forever. Eventually, the fuel begins to run out. The outward pressure weakens. Gravity takes over. For smaller stars, gravity compresses the core until it stabilizes again. For larger stars, something more dramatic happens. The core collapses. Atoms are crushed together. Electrons and protons are forced into new arrangements. Matter becomes so dense that familiar physics begins to fail. In the most extreme cases, nothing can stop the collapse. Gravity keeps pulling inward, stronger, deeper, until a black hole is born. A black hole is not a hole in space. It is not empty. It is matter compressed into an unimaginably small region, so dense that its gravity becomes overwhelming, so strong that not even light can escape. This boundary is called the event horizon. The event horizon is not a surface you can touch. It is a point of no return. Cross it, and the future only moves inward. From the outside, black holes appear silent, dark, invisible. We detect them not by what they emit, but by what they influence. Stars orbit something unseen. Gas spirals inward, heating as it falls. X-rays flare where matter accelerates toward oblivion. Black holes announce themselves quietly. At the center of our own galaxy, the Milky Way, there is a supermassive black hole. It is called Sagittarius, a star. It contains the mass of millions of suns, and yet it occupies a region smaller than our solar system. It has been there for billions of years, calm, stable, patient. Most black holes are not violent. They do not wander the universe devouring everything. They sit, they wait, they orbit with the galaxies that hold them. Time behaves strangely near a black hole. According to Einstein's theory of general relativity, gravity bends space and time together. The stronger the gravity, the slower time flows. Near a black hole, time stretches. To an outside observer, an object falling toward the event horizon appears to slow down. It never quite crosses. It fades, redshifts, freezes in time. But for the falling object, time continues normally. Crossing the event horizon feels uneventful. There is no sudden signal, no dramatic line. The danger lies deeper. As you fall inward, gravity grows uneven. The pull on your feet becomes stronger than the pull on your head. This stretching is called spaghettification. Atoms elongate. Structures fail. Matter becomes a stream of particles. At the center lies the singularity, a point where density becomes infinite, where equations break, where our understanding ends. Physics cannot yet describe what truly happens there. Some theories suggest the singularity is real. Others suggest new physics takes over. Quantum gravity, strings, loops. We do not yet know. And this uncertainty is part of the beauty. Black holes are laboratories for extreme physics. They allow us to test theories we cannot recreate on Earth. By studying black holes, we learn about gravity, time, space, and the fundamental nature of reality. In 2015, humanity detected gravitational waves for the first time, ripples in space-time itself. They came from two black holes colliding. Billions of years ago, far across the universe, two black holes spiraled together. Their merger shook space-time, and that tremor reached Earth. Tiny distortions, smaller than an atom, were measured by human instruments. This was not just a discovery, it was a whisper from the universe. In 2019, humanity saw a black hole for the first time, not directly, but as a shadow, a glowing ring of gas around darkness itself. The image was calm, almost serene, a reminder that black holes are not chaos, they are structure. Some black holes spin. When they do, they drag space-time with them. This effect is called frame dragging. Space itself twists. Magnetic fields coil. Jets of energy shoot outward from the poles. These jets can stretch thousands of light years. They shape galaxies. They influence star formation. Black holes are not destroyers. They are architects. Even Hawking radiation reminds us of their subtlety. According to Stephen Hawking, black holes are not completely black. At the edge of the event horizon, quantum effects allow tiny amounts of energy to escape. Over unimaginable spans of time, black holes slowly evaporate. A stellar black hole would take longer than the current age of the universe to disappear. A supermassive black hole, far longer than that. Black holes are not endings. They are long stories, slow ones, stories written in gravity and time. Some theories suggest black holes may connect to other regions of space. Wormholes, white holes, cosmic bridges. These ideas remain speculative, but they remind us that curiosity drives science forward. Even uncertainty has value. Tonight, you do not need to understand every detail. You only need to let the ideas drift. Black holes are quiet places. They do not scream. They do not rush. They wait. Just as you can wait now. Let your thoughts slow. Let the weight of gravity become comforting. The universe is not hostile. It is patient. Black holes teach us humility. They remind us that nature is deeper than our current knowledge. And that mystery is not something to fear. It is something to rest inside. As you lie here, breathing softly, remember this: even in the darkest places, the universe follows laws, even where light cannot escape. Understanding continues to grow, and you are part of that story. Not as an observer outside the universe, but as something formed within it. Your atoms were shaped by stars. Your existence made possible by cosmic processes. You are connected, even to the darkest objects in space. Now you can let go. Let the universe continue its quiet work. Let black holes spin silently in distant galaxies. Let space-time curve and stretch without effort. And let yourself drift, slowly, peacefully, into rest.